All right. Well, we've heard about climate change. We've heard about water resources, and now let's focus a little bit on decarbonization. So, how can actually California help California's ag can help our electricity system decarbonize? So, how can those two help each other? And for those who have wondered, Arian Aghanjazadeh, I know it's a long last name, but Daniela caught it. So let's talk about decarbonizing California. So if you've been following the news, California has a 2045 target for a net zero economy. Senate Bill 100 lays that out. So that means we have to significantly reduce emissions in our economy. So we need to go from about 400 million metric tons of emissions per year to about 80 million metric tons of emissions. And there are certain emissions that we just can't get rid of. There are certain industries, there are soil emissions that we can't fully decarbonize. So that means we need to invest in carbon removal technologies. And that's the gray shaded area. So you might have heard about forest restoration projects. They're engineered solutions that is trying to get carbon into concrete or asphalt. So California has a lot to do to reach its 2045 target. But specifically for this presentation, we want to focus on that chunk that's showing the ag and electricity. That makes about a third of the emissions that happen in California. So let's start by talking about why emissions from tree nuts are important and what's actually contributing to the carbon footprint of tree nut farming in California. So based on a 2012 study that came out of UC Davis, the majority of the environmental footprint of tree nuts in California are dominated by irrigation and nutrient management. So those are the two big chunks that you see, irrigation and nutrient management. So an updated study in 2021, which was just focused on almonds, reinforced those findings. Still, more than 50% of emissions associated with tree nut farming in California, or specifically in this case, almond farming in California, is associated with nutrient management and irrigation. And about a third of those emissions are for irrigation purposes only. So for the purposes of this talk, I'll be focusing more on irrigation. So what's causing the emissions associated with irrigation, and how can we decarbonize that? So irrigation is essentially moving water around. You heard in previous presentations that California is a place where 75% of the precipitation happens in the northern part of the state, but 80% of the demand actually happens closer to the south. That makes California the most hydrologically engineered place on Earth. We've built a massive network of conveyance and distribution system for moving water from the northern part of the state to the southern part of the state. And once we get it through Central Valley, we have another vast network of delivery system that then gets that water from those main canals to farms. A lot of the delivery system is gravity fed, but there are implications about the flexibility of that gravity fed system that ties into on-farm energy use, which I will be talking about later. But the conveyance, which is mainly the State Water Project, the Central Valley Project, is a massive energy user in California. Based on a 2005 study done by California Energy Commission, about 77% of the electricity used in the state is for moving water just for agricultural purposes alone. And that water goes to irrigating 9.6 million acres of irrigated land in California. So a lot of you might say 7% of electricity use in California might not be that much, but that's just coming from one end use, pumping water around. And to put things in perspective, and to break it down, 4% of that water is for conveying surface water, and about 3% is for pumping groundwater. And just to point out, this is from a 2005 California Energy Commission study. I haven't found an updated study. With the drought and increase of irrigated acres, and switch to pressurized irrigation systems, that number might have just gone up since 2005. And so to put that 7% of electricity used by water, for moving water in California in perspective, if you all remember what happened in September 6th of last year, you might have gotten text from the California Independent System Operator. Due to the heat waves, they issued a series of emergencies. They needed us to drop load, otherwise California would enter blackouts. So the amount of load shed that California Independent System Operator needed was about 4% of the total electricity demand. So it's less than how much pumping happens in California. So that 7% could be a huge asset to the grid. If the grid operator can control those loads, or if those loads become more flexible so that they can be used in a heat wave like this, they can be a huge help to stabilizing the California electricity grid. So let's talk a bit more about the electricity grid, because we're going to be then tying irrigation and the California electricity system together. So the California grid, I'm sure everybody has seen the poles and wires. It's a massive network of generators, generation assets, transmission and distribution lines, which somebody told me it always works in practice but never works in theory. So California has one of the most ambitious renewable or carbon-free electricity targets in the world. By 2045, it needs to be 100% carbon-free. The good news is we are already ahead of our 2030 target. Back in 2020, we hit the 60% carbon-free electricity generation, and that includes large hydro, nuclear, and renewables, which are mainly solar and wind in California. Maintaining a high renewable electricity grid is very difficult because our legacy system is not built for that. So I took this image almost a year ago. I wanted to take one yesterday, but yesterday was not a good example because it was cloudy and rainy, so we didn't have a lot of solar generation. So I wanted to take a spring day that's representative for most spring days in California. So I used the image from last year. So as you can see there, we have about 50% of electricity in that day coming from renewables and the rest coming from natural gas. So speaking of the challenge of a renewable electricity grid, let's take a look at what happens during a course of a spring day in California. It's the same day that I showed earlier, February 23rd, 2022. Spring or late winter, early spring are unusual days or unique days for the California grid, which really puts it to the test. Those are the days where we have a lot of solar generation because they're typically sunny. It's not this year, but typically we have a lot of sun this time of year. But it's also a time of year that temperatures are moderate. We don't have a lot of air conditioning load. We don't have a lot of water pumping for irrigation. So we end up producing way too much solar than we can actually use in the state. So, and that's what this graph is showing. So let me make it simpler. I'm only going to show renewable generation, natural gas, and battery storage dispatches in California. So what you're seeing is during early morning hours, natural gas is satisfying most of the electricity demand in the state. But when the sun comes up, solar assets, that's the blue, starts generating electricity. So the natural gas power plants need to quickly ramp down to make room for that solar electricity. And in the evening, the reverse of that happens. Sun goes down, we don't have enough storage capacity, and those natural gas power plants need to quickly ramp up to meet the evening peak demand and make up for the lost solar generation. And during the midday hours, when we have more solar electricity than we can actually use, we need to store that. Unfortunately, we don't have a whole lot of storage capacity in the state. We have majority of our storage capacity comes from pumped hydro. The battery storage is expensive. The state has been trying to invest in that, but we haven't even come close to capturing all of the overgeneration that happens in the state. What that means is, What that means is a lot of times we have solar generation that we can't use, so we curtail that, so we don't end up using that solar electricity. And something that happens on the wholesale market is that during those times of overgeneration, the price of electricity goes to zero or negative. So those generating assets are trying to get rid of that electricity, otherwise they have to initiate shutdown, which is problematic for their operation. So part of my research is to look into low-cost alternatives to battery storage, and agricultural pumping could be a great candidate for that. So during hours where the grid is under a lot of stress, during those ramp hours where natural gas power plants need to ramp down quickly and ramp up quickly, which is, again, very problematic for them and also causes a lot of emissions when natural gas turbines are ramping up and down. Can we pump less water during those hours, but instead pump more during hours where we have excess solar generation to absorb that as a low-cost alternative to batteries? And utilities, investor-owned utilities, and the California Public Utilities Commission have also been trying to update the time of use periods, the peak periods, the demand response program to respond to the changes to the grid. So if you remember, historically, peak periods from PG&E used to be between the hours of noon to 6 p.m. Those were the hours when it was hot, everybody was running air conditioning. But now, those are actually the hours where we have excess solar generation. So it doesn't make sense to make those hours to be more expensive. We actually want those hours to be cheaper so people can use more electricity. So the new peak periods that got approved a few years ago are between the hours of 5 to 8 p.m. You might have, depending on the rate you're on, it might be 4 to 9 p.m., but it's been shifted later in the evening to address those evening ramp up. So the good thing about the new peak period is that they're short enough, they're about 3 hours instead of 6 hours historically, that a lot of irrigation schedules, assuming there's automation in place, can accommodate them. The problem is, if you don't have automation, they happen in the evening. So sending workforce out there at 5 p.m. to turn pumps off and then turn them back on at 8 p.m. might be challenging. Something else that hasn't been rolled out, but it's being tested and piloted by some utilities and some technology companies, is dynamic pricing or real-time pricing. So in reality, we, as consumers, we only see a flat price for electricity or a tiered price for electricity. But what happens in reality, that price is changing every 15 minutes. So the idea for dynamic pricing is that can we aggregate those prices and then pass it on to the consumer where they get charged based on the hourly price of electricity. So as you might notice, there are certain hours where price of electricity is negative, and then there are certain hours where the price of electricity shoots up. Could it be possible that we can see those prices, set our irrigation schedule so that we only pump during negative prices or very cheap prices? So in some ways, pumping could start generating some revenue. And these are being piloted. These are way into the future, but it's coming. I mean, I don't know when, but that's what is going to happen in the future. So, and one last thing I wanted to mention was all of this renewable integration, climate change, is threatening the reliability of our electricity grid, and it's also increasing the cost of electricity. So you might have all heard about the wildfires that's been happening in California as the result of higher temperatures and drier climate. Between 2016 and 2019, we had 3.7 million acres of forest in California being burned. In 2020 alone, 4.2 million acres of forests were burned. Some of these forest fires were caused by transmission lines, high-power transmission lines, so that put utilities under a lot of pressure to start doing vegetation management, and also implementing public safety power shutoffs, which increase the cost because they need to spend more money doing vegetation management, but also it creates more dissatisfaction because a lot of customers lose power during those public safety power shutoffs. So as the implications, the emergencies that have been being called by the grid operator has been going up. So these are the number of different emergencies that the California Independent System Operator has been calling over the years. And you can see in 2020 and 2021, we see a significant increase in those emergencies. The number of public safety power shutoffs that's being called by utilities is going up, and customers and the outage duration, that's the red line, has been going up over the years. That means we can't rely on our legacy electricity system anymore. And a lot of customers might end up having no power. Let's say you lose your power during a hot summer day, that means that's hours of lost irrigation. And also because all of this puts a lot more pressure on the utility, then they need to pass that cost on to the consumer. So over the past decade or so, you'll see a constant increase of agricultural rates. So that's about 65% increase in the agricultural electricity rates over the past almost 12 years. And just this past year, there was another rate hike, 16% increase in ag rates. And as you can see, in the following years, we'll see another 2.9% increase and another 2.3% increase. So constantly, the cost of electricity is going up. So what can be done? And this can go beyond just on-farm irrigation. I'm talking about on-farm and also a lot of irrigation districts, if there are any water agencies or irrigation districts in the audience. The way irrigation districts deliver water can have implications on when and how farms pump that water. So investing in automation and modernization is key. So if you have an automated system, if you have automated pumps and valves, you can take advantage of different electricity rates and different electricity prices. Without automation, it would be very difficult. Same goes to, we've seen a lot more investment in modernization on the farm, but still we haven't seen a lot of automated pumps, a lot of automated valves. A lot of those are still operated manually. But again, everything that happens outside the farm, on the district side, on the irrigation district side, is also important, because if the irrigation district cannot deliver that water on demand, then those growers have to rely on pumping groundwater, which is costlier. It uses more electricity. And if you're only receiving surface water and you're tied to the irrigations, the schedule that the district dictates, that means you cannot take advantage of the dynamic electricity prices or even time of use, because if you commit for a 24-hour period of water delivery, you have to pump that water over that 24-hour period. Another thing is on-site generation. So it's been getting a lot of traction. There are federal and state incentives. Based on a 2012 study, 8% of California farms have some sort of on-site renewable generation. It could be biomass, it could be solar, but microgrids are becoming more reliable, and solar technology is becoming cheaper. So there is opportunity for growers to install solar modules and a microgrid on their farm, so that they can rely less on the utility and rely more behind the meter. And with that, I'll take some questions and end the talk.
Thank you. Questions?
I'm not sure if I have a question or just a statement, but I agree many of the districts are not flexible enough to provide water on demand. So then it becomes easier to just use your groundwater, your pump. And so I don't know what's being done. It seems like there's been a lot of conversion to low pressure systems in row crops and, of course, the nut crops, the trees. But I haven't seen any. I haven't seen any districts how they're accommodating that.
Danielle and I are actually working on a study to look into what are the opportunities and what are the barriers for irrigation districts in investing in that kind of technology, in modernizing and being able to deliver water on demand. Because I've heard claims that we deliver water on demand, but then that on demand is actually within a 48-hour notice, and then you have to get that water over in the next 24 hours. A true on demand is like opening a tab or turning off your like groundwater pumps. A lot of it has been historically, and we've done some literature review. Historically, there's been a lot of attention or focus on the farm. So all the state funding has gone to on-farm modernization. Less has gone to everything that happens off the farm. And hopefully there will be a shift soon where the state and the federal government realizes that we focus too much on the farm, so let's focus on the irrigation district side because it's a connected system. And the other controversial thing is for a lot of these districts, water could be fairly cheap. So why would you invest in better managing a resource that's fairly cheap? So that's
Okay, mine's kind of a two-part. It seems to me that we need to have our grids re-engineered so that there can be more localization. I'm not sure if that's a real thing, but it seems to me. And the other one is, do you see any move toward, like on the solar systems, that we can switch off of the grid and just use the power direct during those really peak times and not overload the grid, just use it direct?
You're talking about behind the meter solar where you do some sort of net metering. So that behind meter generation has actually become a challenge for the utilities. When in the early days, utilities never predicted so much behind the meter installation. So that's something they never planned for, and now they have all these. And in the early days, all utilities welcomed net zero or net energy metering. That meant you could put energy back onto the grid, and then you can get it back whenever you want it. But now, in a lot of states, utilities are seeing that as a challenge. That's one more thing they need to balance. So they're rolling back all those net metering policies and trying to, yeah. Yeah, I don't know if they have really figured out a better way to do it. I mean, California is still doing net metering. Ideally, you want to make your transition to a microgrid where you use most of your on-site generated electricity and put less on the grid. So that comes with battery storage, coupling that with other technologies. Can you have, let's say, an irrigation pond in a farm example where if you have on-site generation and excess power, can you pump water out of the ground and store it in a pond, and you look at that as some sort of an energy storage?